so now that you have gone through and you have studied and you've learned to name ionic and covalent compounds, we're going to do a learning check. We're going to see if you can name these when they're all mixed up. So you first want to identify each compound as ionic or covalent and then give its correct name. Okay, just a reminder, a compound is ionic if the first element in the formula is a metal or the polyatomic ion ammonium, because it's the only one that has a positive charge, and it's also going to be bonded to a nonmetal. Okay, so ionic bond is a metal and a nonmetal. And then for a covalent, we're going to have not two nonmetals, and this is when we use the prefixes. Okay, so let's start here. We want to identify each compound. So we have sulfur and oxygen, both of which are nonmetals on the right of the stair step on our periodic table. Okay, so these are going to be covalent. So this should ring a bell. When we have covalent compounds, we use our prefixes. So we only have one sulfur, so we don't have to write mono. So it would be sulfur trioxide. Tri stands for 3, and oxygen, we drop the ending and add IDE. Okay. Next we have BaCl2. Barium is a metal, but it is a group 2 metal, meaning it is a representative metal and we do not need Roman numerals. Okay, so we find Ba and we know that it is barium. So this is ionic, forgot to say that. We have a metal and we have nonmetals. So we have bariums are metal, chlorines are nonmetal. So we have barium chloride. We do not have to solve for the ionic charge. We know that the ionic charge of barium is 2+ because it's in group 2. Okay. Our number C, maybe the most difficult one of the bunch here. We have ammonium. So we have to recognize NaH4, anything in parenthesis is going to be a polyatomic ion. Okay, so if you look at your polyatomic ion chart, then we see that ammonium, like so. So we have but we do not have to represent the, put a Roman numeral here, because we know that ammonium always has a +1 charge. Okay, so there's no need for a Roman numeral, just like with B, which one we just did. And so then we just have to look up, we've got 2 polyatomic ions bonded together. So if you look at your polyatomic ion chart, you will see that PO3 is phosphite. Okay. For D, we have copper. So we know that that's a metal, it's a transition metal, which just tells us that we are going to have to use a Roman numeral. Okay. And then we have this group of atoms. Okay, so if you find CO3, you'll see that that is carbonate on your polyatomic ion chart. And then we have copper, but we do not know the ionic charge because it can vary. It could be copper 1 or it could be copper 2. Okay, so if we need to find what copper our ionic charge is, first thing we have to do is we know that we have a 2- charge on carbonate. The reason we know this is because it's in our table and it gives it to us. So we have CO3 2-. Okay, so the only way for us to equal 0, we have a 2-. We are going to need a +2. 2 minus 2 equals 0. And okay, that is true, but just all my mistakes, it's easy to make them. Okay, we've got 2 copper atoms. Okay, we can't forget that. We've got 2 copper atoms. We only have only have 1 carbonate. 0. Okay. So our ionic charge only has to be 1. So just to show this again, so we have copper and we have carbonate. We have to use a Roman numeral. So copper 1 is going to be copper 1. But how we find this is we've got copper, but we have 2. So if we look at our formula, we've got 2 copper atoms. So we want to find what our charge is. And we have only 1 carbonate with a -2 charge. So our x only has to be equal to +1, because 2 times +1 minus 2 equals 0. So our x is equal to +1. Okay, and so to better show that there, you have to be sure you take into account the number of atoms that you have in the formula. Okay, we have E. Now we have nitrogen and oxygen, both of which are nonmetals. So that these are covalent. This is a covalent compound. And we have to write out dinitrogen. And we would have tetroxide. Okay, so you may be thinking, where did the A go? But we dropped the A because we have a double vowel. We've got an A and an O, so you drop the first vowel. So we get dinitrogen tetroxide. Okay, if you were able to go through these, this should be a good start. There's more practice under the extra practice and handouts tab on Blackboard, as well as practice on Mastering Chemistry as well. Thank you.